Now that we've finished talking about factory methods, let's start talking about completion stage methods. And we'll see there's a couple different parts to this because there's a number of different completion stage methods used in our CompletableFuture implementation of the ImageStreamGang case study. We're going to start by looking at a method that's implemented here called download image async, and we'll take a look at the completion stage methods that it uses. So if you recall, download image async is a behavior that's passed into map. And the idea here is it will go ahead and download non-cached images. That's what its purpose is. And you can also guess by the use of the suffix async that it's going to do it asynchronously. So it'll asynchronously download the image and then ultimately arrange to get it processed. And while it's arranging to get it processed, that image will be stored in memory. So it doesn't actually get into the file system until it's been filtered and transformed and stored. As before, we're going to use optionals, and if there are empty optionals, that just means that something was already downloaded before, they were cached, and so they're just going to be ignored in everything later in the pipeline. So this is a very clever use of optional to basically get the equivalent of filtering things out without having to go with filter, which would require us to convert the completable future into the actual object to which the future pointed, which would be inefficient because we have to use joins or gets all over the place. So this particular use of map returns a stream of completable futures to optional images. And if the image is in the process of being downloaded, then it'll have a value. If the image has already been cached earlier, then the image will be empty and therefore will be ignored by these later phases in the pipeline. So here's the download image async method. And it's really quite interesting. So you can see here it takes a completable future to an optional URL. And at first you might think, well, that's way complicated, but actually it's really straightforward. And the reason it's straightforward is that optional makes it really easy to handle empty and versus non-empty values. So let's take a look and see how this works. So first of all, URL future is a completable future, and that completable future will be triggered to have its completion stage method called when the future completes. And the future will complete in this particular case once we know whether an image has already been downloaded or not. So whether it's cached or not. And that's done, if you recall, by the factory method, the supply sync call we looked at when we checked to see if an image had already been cached. So when we know whether an image has been cached or not, this future will trigger. And what happens then is there's a call to a completion stage method, which is, in this case, it's then apply async. And this completion stage method will register an action that, as usual, is not executed right away, but it's only executed after the URL future parameter has completed and triggered. So let's take a look and see what it's going to do in this case. So it's going to use the map method on the optional. So optionals have a method called map. And the method on map is pretty cool on an optional. What happens here is you pass in some kind of behavior, which in this case is blocking download. It's a method reference. And the blocking download method reference is only going to be invoked if the URL optional object is non-empty. So if it's empty, in other words, if we've already cached this thing, then we're just going to skip over the behavior that's passed to map, or more specifically, the optional implementation will skip over that. So the way map works on optionals is they only do anything if there's actually a value associated with that optional. So what we're saying here is, if this image hasn't been cached already, then go ahead and do a blocking download. Now, this blocking download is not going to block the calling thread. And the reason it's not going to block the calling thread is because we're going to use the then apply async method. So then apply async, as I'm sure you recall from your assignment and other discussions about completion stage methods, then apply async will run this action in a new, or not a new, in a different thread, different worker thread in the common fork join pool in this particular case. But it only runs it if the optional is non-empty. As before, we have an executor to do this, and that's going to use the common fork join pool. And the way this works under the hood, if we were to peek even deeper down into the bowels of blocking download, we'd see that blocking download uses the managed blocker mechanism that's defined in Java with modern Java and the common fork join pool. Here's what blocking download looks like. You can see here it takes a URL and converts it into an image, and that's in the ImageStreamGang.java superclass. And under the hood, it uses the blocking task call in managed block method. And this is a very helpful class that we've talked about earlier when we were talking about the way that you could essentially control the number of threads in the common fork join pool. And what this does is the call in managed block method wraps the managed blocker interface, and then that is used by the common fork join pool to automatically expand the number of worker threads in the common fork join pool when blocking calls are made. So obviously downloading an image is going to block, and therefore we don't want to chew up a thread in the common fork join pool, worker thread pool. So instead we're going to use the managed blocker, which will auto expand that pool while the blocking takes place. After a short time, then threads that have been expanded will be reaped by the common fork join pool, and then it'll bring it back down to the target parallelism level. The actual work here is done by a method called download image, and this is actually a blocking call. So download image, as you can see here, we'll go ahead and download the content, and that basically goes out, takes the URL, opens the URL, and then downloads it and creates an image from the contents of what was at the other end of that URL. And this is in fact blocking, but of course that's being run in a thread from the common fork join pool. So the overall program behavior is not blocking. We're just giving it to run the computation in the background in a worker thread in the common fork join pool, which may have been auto expanded depending on how many other things are blocking at that time. What's returned by download image async is a completable future, because that's what then apply async returns, to an optional image. And of course, what'll happen here if the optional image object is not empty, if it's got something in it, is that particular completable future will complete when the image has finished downloading in the background in the worker thread that was used by then apply async. So lots of interesting stuff going on here. You can see how subtle it is and why completable futures typically take a little while longer to get your head around. And what's cool about this is how we're using Java streams to guide the various steps, and we're using completable futures in order to be able to run those steps asynchronously. So it's kind of the perfect marriage of two different paradigms that work together more effectively in some sense than either one works in isolation. And we'll show some other examples here in a second when we look at other completion stage methods that are used in our implementation.